Okay, so we're not going on to the last one. I forgot about this part. But we also need to talk about maximum and minimum values. And this really is pretty self-explanatory, I think. But it says, because the vertex is the highest or the lowest point on a parabola, its y-coordinate, it's either its maximum or its minimum value of the function. The vertex lies on the axis of symmetry, so the function is increasing on one side and decreasing on the other side, okay? So when it's turned upside down like this, it's increasing here, it's decreasing here. It's kind of like a roller coaster. So here it's decreasing and then it's increasing. And it changes direction at this x value right here. Okay? So let's look at some examples, of course. So finding a minimum or a maximum value. So find the minimum value or the maximum value of this function. Describe the domain and range of the function and where the function is increasing and decreasing. And pay attention because this is going to be on the review and on the test. Okay, so first of all, we notice that it does open up. So if it opens up, okay, like this, it means we're going to have a minimum value right there. Okay? So in order to find that, we need to find the vertex. So x equals negative b over 2a. Okay, so negative b is a negative 2 over 2 times a, which is 1/2. Okay, so that's 2 over 1. So my axis of symmetry is x equals 2. And when I plug that in, I have 1/2 times 2 squared minus 2 times 2 minus 1. So this is 2 times 2 is 4, divided by 2 is 2, minus 4 minus 1 gives me a negative 3. So my vertex is 2, negative 3. So 2, 1, 2, 3. All right. And I know it opens upward, and it doesn't tell me to graph it, so I'm just going to do a really rough graph right here. It's probably not quite correct, but that's what I'm going to have it look like. Okay, describe the domain and range. Hopefully you remember that the domain is describing any x value that can be in this function, okay? And for this, it's all real numbers. Okay, I can put any value of x into here that I want. However, my range isn't down here. The parabola starts here and goes up. So my range is y is greater than or equal to negative 3, right? I can't go under negative 3, and the range is my y value, so I'm looking at that. I'm never going to get anything under negative 3. So it's y is greater than 3. And if you're using interval notation, which you can use, it is negative infinity to negative 3. Okay, so that's using interval notation. All right, the last thing is to find out where the function is increasing and where it's decreasing. So if this were a part of a roller coaster, okay, this part right here is decreasing. This is when we're coming down. You probably can't see this very well. Okay, and this is where we're increasing. So at what point does it turn? And this is where it gets a little bit confusing because we look right here at where it turns, but what we're really wanting is the x value. So we already talked about the y value, that's the range, but the x value tells us where it changes from decreasing to increasing, okay? So I'm coming along here, and when x is 2, Okay, right here, right along this line right here, when x is 2, that's when it switches from decreasing to increasing. I'll use a different marker. Okay, so it's decreasing. It's coming down. I'm going to do this in interval notation, but it's coming down. So it's coming from negative infinity, and it's going to 2. 2, right here, is where it switches. Okay? So that is where it's decreasing. It's increasing. It's increasing from 2 to infinity and beyond. Sorry, I just had to say that. 2 to infinity. Okay, so decreasing from infinity to 2, right, to this point right here, and it's increasing from 2 to infinity. It does not include 2 as a point, okay, because that's the point at 2 is it's not doing anything. It's not increasing or decreasing because that's the vertex. So we don't include 2 here. Okay. So I want you to try this one. So go ahead and pause. All right, so coming back, find the minimum value or maximum value of this function. Describe, so that's one thing we're finding. We're finding the domain and the range, and then we're also finding where it's increasing and where it's decreasing. So it's actually quite a bit, and like I said, this will be on the test. So, okay, so I'm looking, and first of all, I see that it's going to open up. This is positive. I'm a positive person, I'm smiling, so I'm opening up. So that means, since it opens up, I'm gonna have a minimum. So let's find the vertex. So x equals negative b over 2a, which is going to be negative 16 over 2 times 4 is 8. So my axis of symmetry is negative 2. Okay, and then I plug that negative 2 into my function. And I guess if I'm writing it perfectly correctly, I would do f of negative 2 equals 4 times negative 2 squared plus 16 times negative 2 minus 3. So this is negative 2 times negative 2 is 4, times 4 is 16, minus 32 minus 3 gives me, and I have this written down, negative 19. So I can't even really graph this. This is way, 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 way down here. So we'll pretend like this is negative 19 down here. It's gonna open up. It's gonna open up like that. But they wanna know, okay, the domain. The domain is again the x values. What, going backward to forward, well, going left to right I mean. Okay, what values of x can there be? And the answer is all real. I can put any value of x I want in here, they'll all work. I'm not taking the square root of a negative number or anything like that. So I can put in anything. But my range is stopped. It's stopped right here at negative 19. These are my y values. So my range is y is greater than or equal to negative 19. So y is greater than or equal to negative 19. And if I write that in interval notation, I have negative infinity to negative 19, and that negative 19 is included. Okay, so decreasing and increasing. Ooh, I am way over time. Decreasing, we're coming down here again, right? And I know it's misleading because we keep thinking we're gonna we're going to, this is our point right here where we stop decreasing, and that's true, but we're looking at the x value of where it's decreasing, all right? So if I'm coming along here, it's decreasing, 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 boom, now it's increasing, okay? So it's decreasing from negative infinity to, where was it? -2, okay, because it's the x value of the vertex, okay, -2, and it's increasing from -2 to infinity. So decreasing, 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 stop. Now it's increasing, increasing, increasing. Okay, I hope that makes sense. We'll finish up the lesson maybe in the next video.